For everyone that's here, hello and welcome to Machine Learning Live, powered by Amicus Recruitment and the Live series. For those of you who don't know who Amicus are, we are a specialist IT recruitment agency that focus on three key areas: Python, Golang, and JavaScript. Now, as you may know, but if you don't, my name's Jordan Hayward, and I'm a specialist Python consultant with a particular focus on the Austin area, but also remote opportunities throughout the US as well. Now, today I'm joined by the outstanding engineer, Eduardo Apolinario. Apologies if I've butchered the pronunciation there, Eduardo. But Eduardo currently works for a young AI company called Union AI. And today, Eduardo will be given a talk on one of Union's cutting-edge products, Flyte, which is a machine learning-focused open source tool used for orchestration. Now, like all our webinars, this will be interactive, and Eduardo is ready to answer any questions you may have throughout. So if you do have any questions, please stick them in the Q&A tab at the bottom of your screen, and either myself or Eduardo will get to those questions as and when we can. So yeah, that's it from me. Eduardo, I'll hand over to you.
Amazing. Jordan, thank you. Thank you for the introduction. Yeah, as Jordan said, my name is Eduardo. I work at Union AI, which is the company behind this open source project called Flyte, which is the main topic of this presentation today. So let's get going. First of all, let's talk a little bit about, what we're going to talk about here. So Flyte attacks some of the fundamental problems that you see when you start thinking about, deploying machine learning models to production. Then I'm going to talk about the actual programming model behind Flyte, how we can use Flyte to build, ML pipelines, a little bit about, who is using Flyte. You're in good company, and how you can get started with Flyte. So first, why did you even build Flyte, right? Like, it's not like ML is this solved problem, but at the same time, we've had multiple people attacking this problem from different angles, and here's ours. We think that there is a fundamental challenge in building ML applications when it comes to even like choosing what are the components of your application or your ML application. You can see here, I listed just a few of the solutions in the different steps of producing an ML application. Just looking at this, it makes my head dizzy. So we looked at this and said, hey, Flyte understands fundamentally that the ML tooling space is evolving rapidly. A second challenge, it has to do, with how iterative in the process of producing ML models is. Like you're constantly in this cycle where you start from the data, you train a model, you evaluate it, you publish, an experiment, track the results. But if you're doing this in an ad hoc manner at any step of the way, you can get, invalid data, or you might even, be in a place where you can't find the results of a successful experiment, which it is like from people who come from a software engineering background, who look at this and like their eyes will gleam and say, oh my God, we have a great opportunity here in a different problem space, right? Challenge number 3 is it is really hard to scale any of these homegrown solutions across, multiple teams. So Flyte is targeted at like also solving this problem, where we want to make sure that people can communicate effectively across teams using Flyte as like the medium. Another great challenge that all is well when you think about, writing an ML pipeline, but sometimes you need to, especially when you're in a bigger team, you need to start worrying about library dependencies between different projects, or multi-tenancy, you know, like you have projects that interact with each other and they might be slowing down the experiments just because they're running the same hardware. Or how do you control costs, right? You can just like let the teams just run any experiments unchecked, and you don't want to be surprised at the end of the month with a cloud provider bill that it crosses the $1 million mark. So Flyte is also targeted at like making sure that platform teams have a model to ensure that auto scaling is within bounds. Like you can execute models independently. You can control costs. You have like all this visibility into the actual platform, like that your workflows are running. And finally, we also recognize that most of the frameworks that exist today, or at least at the time when, you know, Flyte was initially designed a couple of years ago, they think of the workflows as or pipelines as this static structure, but in several cases, even like very simple cases, like you need dynamism. You need a way to basically execute a workflow across, you know, a huge search space. Here's one example: like you have, you know, you're doing hyperparam optimization of a certain model, and you're just doing grid search, and you want to be able to like have these inversely parallel tasks that, you know, just do the search in the space using the actual programming model that, you know, Flyte proposes. So yeah, those 5 compose this solution that we named Flyte. It's an open source data and machine learning or orchestration platform that enables highly concurrent, scalable, and reproducible workflows. That's a mouthful. It's a big sentence. So let's break it down a little bit. All the Flyte code is open source. You can go to flyte.org/Flyte and see every single component that comprises the Flyte platform. Most of the examples that you're gonna find, they are targeted at, you know, the data and machine learning problems. So, you know, training or running big computation in Spark clusters and stuff like that. And all that packaged within a model that allows you to think more declaratively in terms of like how the things run, as opposed to, you know, the usual stuff where you're more describing the bits of like, hey, copy this file from here, write it there, like load this. Like Flyte provides you with an abstract layer that allows you to express your workflows or pipelines in, you know, at a higher level. And we're gonna dive a little deep into like what this means. But let's talk about some of the core concepts of Flyte. First, we have tasks, and tasks are the smallest unit of work in Flyte. They are a version. You have to specify what language the task is written in, but Flyte understands, you know, multiple languages. It maps to a plugin in the backend, so you can think of it as like, hey, I have my workflow that is composed of tasks, and each task runs potentially in a different language. Not necessarily that you'd like to do this. It's just that it is present in the programming model. And the main point here is that since tasks are the smallest unit of work, Flyte provides this concept of strong interfaces at each task boundary. So on the right hand side, you see like this rectangle split in like 3 parts, right? Both in terms of inputs and outputs, Flyte will make sure that whenever you are composing your workflow, the types of the actual inputs and outputs match when you describe your computation using workflows. So that's what I mean by strongly typed. It bears the same resemblance to what you expect in static languages like, I don't know, C++. Even if like most of the SDK that you see that is supported by the Flyte team is written in Python. Like Python has been adopting type hints and types over the last like 10 years. We lean very heavily on that, but the idea is tasks are the smallest unit of work in Flyte, and they are strongly typed. The second fundamental concept is a workflow. The workflow is the abstraction that allows you to compose tasks. So in other frameworks, you might see workflows named as like pipelines, but in Flyte terms, we call them workflows. Similar to like how tasks work, workflows are also strongly typed. So you get a reassurance from Flyte that the outputs of successful executions of workflows have a certain type or certain types. We're going to see a few examples of like how workflows look like later at presentation, but keep in mind that workflows are this declarative version of your computation. If you squint a little, look at the right hand side of the slide, you have a white box that comprises the workflow, and inside of it you have a very small computation composed of tasks that you have like a task at the top that produces two outputs that are used as inputs of two other tasks and workflows. So workflows can be used within other workflows. So you have this notion of like sub workflows also, right? But again, workflows are the definition of how your computation actually looks like. How it's going to be run in the backend, that is all this heavy lifting is done by Flyte, but workflows again is the abstraction that you use to compose tasks to define your pipelines. They're also versioned, and as I hinted at challenge number 5, you can have dynamic workflows, but let's not get too crazy on that. Then the third core concept of Flyte is what we call launch plans. You can think of them as like the spare of a workflow in a schedule. This is just so you can have workflows that run at a fixed schedule, like think of like cron jobs of your you also have this idea of projects and domains in Flyte. This is just to help you separate the environment where your workflows are going to run. Think of this as your CI/CD pipeline, where you have a project. Let's call it, I don't know, data ETL, and you have like 3 domains: development, staging, and production. Like you can totally see where you can have this ML ops like feedback loop where your workflows are first, at the PR level, they're pushed to a development cluster and domain. You test your things there, and like it finally follows the usual path to production, where you deploy to staging, run some tests, finally get to production. But the main takeaway here is that this idea of domains and projects is integral to how we think about Flyte projects. So think of it as like this logical grouping of tasks and workflows that are split by project and domain. And just to bring the point home, in Flyte, we do a lot of work to ensure that your workflows, the types between the tasks in your workflows actually match. Here's I'm showing an example of a workflow that takes an integer as an input. It has a task called create data set that produces a data frame. But we are in the development stage where people are creating these tasks separately. You have a train model function or task that takes as an input a list of dictionary as opposed to a data frame. This means that when you try to register this workflow at Flyte, Flyte's gonna give you an error message saying, hey, you have this workflow and you have these two tasks and the types don't match between them. So it's almost as the usual like compile time errors that you see in like static languages. You get this, but at the workflow level with Flyte. Again, another interesting feature that Flyte brings to the table is that, remember, like tasks are these small units of work, and they are independent, right? And they're strongly typed. So we lean heavily on this to allow you to be as free as possible when describing your workflows. So on the right-hand side here, I'm showing you a workflow that contains like 4 tasks. The first one at the top, it runs on a Spark cluster and it produces outputs. And we have a task that runs as just like regular Python code. And on the right, you have like R and SageMaker at the bottom, like just joining the outputs of the upstream tasks. But again, the idea is that you can think of each task as the smallest unit of work, and they can be expressed in a lot of ways, ranging from just writing regular Python to even like more exotic languages like R, C++, Scala. We also have this notion of a backend plugin. So here, the very first task of this workflow, we have a task that runs in Spark. And the way you express this is that you teach Flyte about the fact that whenever a task of type Spark comes up, run this bit of code that handles the process of spinning up and tearing down Spark clusters. Again, just to bring the point home again, Flyte is language independent. We have, most of the ML libraries and the libraries are in either in Python or R, but Flyte doesn't. It has the flexibility of you picking what is the actual runtime environment that you're going to use. Most of the code that you're going to see shared around will be written in Python, but again, that's not a strong requirement. You can use R for all intents and purposes. And we already hinted at this, but again, when you think of workflows are your declarative structure of how your pipeline looks like. Here, I'm just writing or showing a simple workflow that does something that I can, something very simple in that the first task, the Spark task, it when Flyte decides to run that task, it's going to spin up a new Spark cluster, run the code that you defined in your task, tear it down. Same thing, like let's say you have, in the second task, you have this Python code that's using PyTorch and needs, 100 GPUs to run some computation. You can easily express in Python using the Flyte SDK this kind of requirement where you have, some Python code that needs to run in GPU. Again, Flyte does all the heavy lifting to set up the environment, ship your code to GPU, run it there, get the outputs, produce this strongly typed version of your output. And as a third example, we just have, people are using Ray to run computations, use Ray to do, like, Ray is great distributed computing platform, and Flyte integrates well with it. It follows a similar model as Spark. You have code in the backend that takes care of, setting up a Ray cluster, shipping up your code, monitoring for, the completion of the code, tearing down the Ray cluster, and eventually, producing these strongly typed versions of your outputs. But again, the idea is that you think of your workflows at a declarative level. You're not thinking so much about how to spin up clusters, how to run things on GPUs. Just let Flyte know that these are your requirements, and Flyte will work to get to fulfill those requirements, essentially. I think here's a great stop point. So, Jordan, let me know. I can't see the chat. Do you have any questions? Does anyone have any questions now?
Yeah, we've got one. Only one
Cool.
at the moment, though. So it's can you have a task in 2 different languages at the same time?
Good question. So the answer is no, but just because a task really is the smallest unit of computation. But you can definitely have like 2 versions of the same task using, like, different versions of Python with different names and versions if you want, but they have to be separate tasks. Does this answer your question? Whoever asked it.
I think so. If it hasn't, feel free to chuck in another question. But yeah, that's the only one we've got for now. So feel free to crack on.
Okay, so let's do this. So now we shift gears a little. We're gonna just talk a little bit about how to use the Flyte Python SDK to write a very simple application. So first, let's talk about how you ship code from your local dev environment all the way to a Kubernetes cluster when thing is actually scheduled and run. So starting from the left, you wrote your workflows. You're using the Python SDK. You see like the top left rectangle say, hey, from Flyte import task and workflow, and you define your workflow as, you can think of it as like this graph. Jordan, do you see my mouse pointer, or this is not a thing?
Yeah, I can see it. Is it in the left hand side on the grey screen?
Yeah,
it's very small,
yes.
But it can be seen if you.
Okay, I won't rely on that. I will just point to things and describe. But again, the idea here is you have your code, your Python code. It describes a workflow. It has a bunch of tasks, and you go through this process that we call packaging and registration. This is you interacting with a Flyte cluster to go through this phase in Flyte that compiles your code. And what I mean by compilation here is Flyte does this work to understand how it can parallelize your workflow so that you don't have to specify, hey, run this, then run this other task. Like Flyte automatically deduces that. And it also catches errors of, type mismatches, or you're using an undefined task or something. Like Flyte has this compilation phase that provides feedback for you immediately if there's anything wrong with your workflow during registration phase. As part of registration, you have to let Flyte know what are the the actual images, or in here I'm saying like Docker images that you're going to be using for your tasks. So each task, again, is the smallest unit of computation. You can think of it as like running like a single container in a pod that points to, you know, a specific image. So it's at registration time that you let Flyte know that for a specific task you're going to be using a specific Docker image. And after you go through registration and you get an okay from the Flyte compiler, now it's time for you to kick off executions. We have a few entry points of like how to do this. You can do it through the UI. We also have a few CLIs. There's one written in Go, run one in Python, or even from within the Python SDKs. So if you're a Python shop and you don't want to reach out, you know, to Go or like some other CLI to build your CI/CD pipelines, you can totally just stay within the realms of Python to kick off executions, check the result of executions and whatnot. But let's say, you know, you have your workflow, you have your tasks, you registered, you're ready to kick off an execution. What is this app that we're going to be building here real quick? So going to be using this data set that allows you to identify, given the build length and the depth, what is the type of penguin. So it's an open data set. Just go to Patterson Horse like github.io, Palmer penguins. Multiple people have used this data set in the past. Here's just a few renderings of, you know, how the two features that are going to be using they are distributed. So let's get started. We're going to write some code. So here's some Python code that doesn't do anything magic. Here, just, you know, specifying some of the features and importing specific functions from the Flyte SDK and scikit-learn, which is not super important. Next step is to start thinking about the tasks. Again, tasks are these the smallest units of computation. But if you forget about this and just think in terms of, you know, tasks as being these Python functions, here's a quick example of, you know, you just writing tasks to cover all the usual steps that you see in an ML pipeline. First, you know, you get data from somewhere. Here we're just, you know, getting some features from that data set that we showed that comes from scikit-learn. Have split data, the usual, you know, just split your data set in like two sets, the training and test. And in the case of the model that we're going to be training here, is really that simple model. It just does logistic regression on the features that we defined, those 4 features. Finally, an evaluation just so that you can check if the training did something reasonable. But again, you're just writing Python, right? In the backend, each one of these tasks will run separately in its own container, and Flyte will do the mapping between, you know, all the inputs and outputs and how to parallelize your job. So how do you combine these tasks into a workflow? So here's how the workflow would look like. Again, we're just defining a Python function using the Flyte decorators exposed by FlyteKit, in this case, workflow. And the workflow, if you read this code, it looks like Python, right? You're just like writing, hey, get me the data, which uses the get data function that we defined in the previous slide. Then split the data in the training data set and the test data set, do training, do evaluation, and return the model. In the backend, Flyte will run each one of these functions separately, and we'll do the mapping between, you know, the inputs and outputs for you. So training model could, for all intents and purposes, be using, you know, a gazillion GPUs if you would like. Nothing would change in your code besides going here in the training model function, and just in the task, in the invocation of the task declarator, you just say, hey, I want 100 GPUs. But let's keep going. After you wrote your code, again, just going back to how this graph looks like, you need to let Flyte know that there is a new workflow, a new set of tasks. So you go through this process of packaging and registration, right? So here, I'm just showing you the two options of commands that you could use to package your code and register it. So you do pyflyte -- package, and then the path to your workflows. And this will generate, a zip file that contains the definition of your tasks and workflows and launch plans. And you finally talk to the Flyte backend via the flytectl CLI, which is to flytectl register. Here are my files. And at the bottom here, I'm just showing you how this thing looks like in the Flyte console, which is the UI that Flyte ships with. In this case, I'm just showing you there's a new workflow called workflows.example 00 intro.training workflow. Notice how the inputs and outputs are called out here. This is important because, as I said, workflows are also version and strongly typed. So speaking of being strongly typed, you can finally kick off an execution. Here, we're using the Flyte console, but again, you have other options as well. Notice that I'm highlighting the inputs to this specific workflow. So it takes hyperparams as a struct, JSON blob, random state as an integer, and test size as a float. And after this thing runs, you get this this beautiful diagram of how your workflow actually ran. Each green box here is a separate task, and as I said, each one ran in a different container separately. Like does the work of capturing the inputs, kicking off the execution, retrying, and all that. You can inspect. In this view, what we call the graph view in Flyte console, you can inspect the inputs and outputs of each particular task. Here, I think I had clicked on one of the evaluate functions. And again, we touched very briefly on launch plans earlier in the presentation, but here I'm just showing you an example of running this training workflow on a schedule. In this case, at the top of the hour, we would be running this workflow, these default parameters. So we're just defining hyperparams here, but you can think of it as like you can define any inputs. Obviously, you can name launch plans here. I'm just saying, hey, I'll be running this workflow called training workflow. The name is schedule training workflow. It runs every hour, and here are some of the default inputs to it. But it doesn't stop there. Like Flyte allows you to cache the result of intermediate steps in your computation. So here we're just instructing Flyte that the function, the task train model now is cached and has a specific version. This is important because you can refer to specific versions of executions of tasks across multiple workflows. So think of the case of you have different data scientists working on using the same data set. They want to share the model across the experiments they're running. You'll be able to do this without having to reach out to any any other like caching solution. Like this is supported by default by Flyte. And the way you do this with tests, just you pass those two fields. You say that you want to cache a specific output of a task, and you tag that with a version. As part of the programming model of Flyte, you also have this ability to run a map, or for those who have a background in functional programming, a map task really is like a map. You receive a sequence and a function, and map task will essentially do the work to run that function over that sequence, and it uses the similar semantics as the usual tasks. So each task runs in its separate container, and Flyte will do the work to parallelize the work, to make sure that you can go as fast as you can or as you want. In this case, I'm highlighting the fact that I'm mapping using this function called train model, and I want to specify concurrency into 5, which means at most 5 instances of this this map function will run at any point in time. But if you don't specify concurrency or you set it to 0, it spins up as many pods as possible. Obviously, this is configurable in the backend as well, so you don't have to worry about when you're like writing your workflow. But the main point here is that Flyte has this concept of map tasks. Like sometimes in workflows you have these embarrassing parallel tasks. Just leverage map tasks if that fits your use case. I talked about how Flyte takes care of spinning up compute platform like instances. And what I mean by this is, let's say you're a big fan of Spark, and you want to use Spark in your Flyte workflows. Using Spark is as easy as just instructing a task that you're going to be using Spark. So on the left-hand side on this rectangle, we're just like defining a task called preprocessed data PySpark. Notice how you're using like the PySpark data types like data frame to return one of those objects. But the main interesting bit here is that you're going to be shipping this code that's defining this task to run in a Spark cluster that is spun up specifically for this task. So Flyte will do the work to spin up a Spark task, a Spark cluster, using that Spark configuration that you define in the definition of the task. So, you're gonna have like 2 executors, 1 core in the driver, and use at most one gig of memory. And once the task finishes successfully, Flyte goes and tears down the Spark cluster. A very similar idea is also applied to Ray tasks. So you can have some code that runs in Ray, and you want to use this in a Flyte workflow. You can very easily just express your task, using the usual types that you use when you're interacting with Ray. And at the task definition, you say, hey, this is a Ray job. And it has like this group name and replicas, like all the configuration that you need to spin up a Ray cluster. That is, again, all managed by Flyte. You don't have to worry about connecting to an existing Ray cluster or anything. And that's not the last feature. Flyte also has this notion of a Flyte deck. So you, as a user, you get to specify visualizations for your objects. So in this case, I'm just showing you a couple of examples how people wrote, for different data types. So on the top left, you have a Flyte deck for an input of a task, and this is just a describe of a data frame. But really, you are free to produce any HTML that describes your data. Flyte ships with a few renderers. There's renderers that understand data frames. There's a renderer to produce HTML from Markdown, so you can use that to generate your reports. And yeah, that's part of the Flyte programming model. And I hope this gave you a sense of how powerful the Flyte as a system can be. And if you're just wondering who's using Flyte these days, here just listed 4 examples. People who have been using Flyte at an immense scale. From Spotify doing end-to-end profit analysis to Black Shark. They're the company behind a portion of Flight Simulator, or Gojek doing price optimization. It's really incredible that you have companies in these all these different fields. They all leverage Flyte as their backbone platform for running big data and ML pipelines. Quick summary of what we spoke today. Flyte is targeted at the data scientist who just wants to crank models, but at the same time wants the guarantees that you can track experiments, you can iterate as fast as you can, and you won't miss data along the process. It covers the entire model development lifecycle. As I said, you don't want to cache the computation or miss the results of some experiment. So Flyte has a lot of integrations with the usual libraries that people in the ML and data space use, ranging from PyTorch, Ray, Spark, Pantera, and others. We have strong evidence that Flyte scales super well from these cases that I showed, where people have been running hundreds of thousands of workflows daily without a hitch. We haven't really touched a lot on how you can do this, but the Flyte programming model is easily customizable. Every point of it, ranging from the client SDKs all the way to how you define backend plugins. And we see this as a big feature of the system, this kind of integrated solutions, where it's easy to share results and code and data between different teams. We saw this happening, Lyft, Spotify, and a bunch of other companies. So it is by design. How you can get started with Flyte? Please visit our website, flyte.org. Check the Getting Started guide. Join us on Slack. We are a very active community. And as I mentioned earlier, the code is all open source. You can go and check how the sausage is made, so to speak. Take Flyte. Go give it a try. Do a quick install Flyte kit, and start from there. Do people have any questions? Or
Perfect. Yeah, there is a couple. There's one, but it's got a few follow-up questions. So
okay.
we'll go through one at a time, and then there's another question as well. So first one, is it possible to run Flyte on a cluster other than Kubernetes?
Ooh, good question. Actually, today we require Kubernetes. It doesn't have to be the cloud. It can be like Kubernetes on-prem, but it requires Kubernetes. We have a solution that we use that's called Sandbox, but it's just like for testing, quick development. It still runs, a full Kubernetes installation inside of Docker. But yes, the TLDR is we need Kubernetes.
Perfect. And then a follow-up to that, where are the tasks outputs stored?
Good question. Yeah, so we haven't really. I should have had a slide here that had a more in-depth architecture, but essentially we use the blob storage of your choice. If you're running on AWS, most likely you're using S3, but if it's GCP, then we use GCS. But everything is copied from and to the blob storage configured in your Flyte deployment.
Perfect. Third one, how does Flyte scale tasks, workflows, and users?
That is a very broad question, but essentially, if you just think in terms of, I think this slide will be a good one to talk about. Yeah. At the end of the day, each task becomes a pod most of the time, right? So Flyte has a built-in scheduler that decides when tasks are ready to run, and that scheduler, you can put some constraints there, but if left unchecked, it tries to make the computation go as fast as possible, and that includes generating or producing kicking off pods for fulfilling your workflow, or the workflows that have been scheduled for execution. So these are some of the levers that you have, but obviously the devil is in the details. Like if you have workflows that are super deep, you have to be concerned about like how much of a breadth factor you want. This is all configurable, but that's just the beginning of the problem of how to scale and still stay within bounds of what people think is reasonable. Does this answer your question? This is a very broad question, and I hope we answered a portion of it. But thank you. Yeah, it's when you see a solution like this, it's hard to think of like how can this scale. But I think the little TLDR is that Flyte tries to execute the computations as fast as it can, given some bounds that you define, given like a number of pods that you want, or like you have this notion of quotas per project and domain. So if you have like multiple teams using the same cluster, but you can say that a specific project can only have 100 pods at any point in time, or another project can only use at most 2 gigabytes of memory at any point in time, and stuff like that. These are some of the levers that we expose.
Perfect. And then there's one final question on this group of questions, and then there's a final one after that. But this one is, how does Flyte compare to other pipeline frameworks, i.e. Prefect and Metaflow, etc.?
That's it's a very Another great question. Thank you, but very broad. I would say that the biggest difference between these orchestration frameworks really comes down to their programming model. In the case of Prefect, which is the one that I have more familiarity, even though not a whole lot. If you again, like, this slide shows like a one big difference that Flyte has when compared to that, is that we do a lot of the work in advance to make sure that you can catch errors as early as possible in your development cycle, and like Prefect doesn't have any of that. It takes your code as is, and has some facilities to like how to ship them to different parts of different clusters. One big difference, I would say, is that Prefect not necessarily needs Kubernetes cluster, right? And when it comes to Metaflow, I find their basic programming model very, very limiting. Again, it goes back, to these basic foundational pieces that Flyte provides. Tasks, workflows, this idea of compiled workflows, strongly typed interfaces. Metaflow doesn't have any of that. Another one that people usually ask about is Kubeflow. So if you want to dive a little deeper on that, we just published a blog post on our website. So go to blog.flyte.org. It should be the comparison between Kubeflow and Flyte right at the top.
Yeah, perfect. So one final question, unless anyone has any more to chuck in, feel free to do so, by the way. But the final question at the moment is, what happens when a task fails? How do you debug a task and data interactively?
That's a great question, and it's an active topic of experimentation within the Union team. Right now, we require a lot of permissions to be able to actually, exec into the pods for the specific task that failed, to reproduce this, to get access to the exact same data that the task had access to when it ran and failed. But we can totally see a much more streamlined experience, where from the UI you can get access to any environment that will allow you to debug certain task executions. That's not the current reality yet. Like, you're still stuck into this mode where you need a lot of Kubernetes knowledge to debug executions. So yeah, TLDR, it's not great because it's not great today, because we require a lot of K8s knowledge from the users to actually go and debug their own task executions, but it's an active topic of investigation. And yeah, keep in touch. There are good things coming in that vein.
There we go. Perfect. So I thought there was another question, but it just said thank you. So I assume answers of questions have been answered there. So but yeah, so that about wraps up today's webinar. So Eduardo, first and foremost, just wanted to thank you so much for taking the time to present. I know you're busy with conferences and presenting elsewhere and your day-to-day job as well, so I really do appreciate it. Flyte looks like an amazing tool on the market from a non-tech standpoint, that is, and I'm sure it'll only continue to grow. So exciting times ahead.
Awesome. Jordan, thank you so much. Thank you, Amicus, for inviting me. And I know we haven't touched on this, but next month we have I would love to just give a sneak peek of, another presentation that will be given by a Union AI team member next month about another one of our open source projects, this thing called Union ML, which it leverages Flyte as a platform, and it really provides a structured way to have to ship ML applications in a more standard fashion, and with a lot of hooks for experimentations and whatnot. So
yeah, perfect. No, that's in a few weeks. I think we've already had a Pandera a couple of months back, Flyte today, and then Union ML next month. So really looking forward to that as well. A massive thank you for everyone to everyone who attended this afternoon and participating with questions. In case you did want to watch it back, or you wanted to share it with your colleagues or team, this will be published on our LinkedIn channel and YouTube channels. So feel free to share the link and keep an eye on that. And then, yeah, as always, if you enjoyed today's webinar, like Eduardo said, we've got next month on Union ML. So if you did enjoy today's webinar, follow us on LinkedIn. It's Amicus Recruitment, and also the live series page as well, and you'll be notified through there. But yeah, once again, Eduardo, thank you so much for today's presentation, and looking forward to having you back again one day.
Amazing.
Perfect.
Awesome.
Thank you. Speak
Thank
soon.
you.
Bye.